Whoa, welcome you guys. So this video, let's talking about this interesting results. Basically, can you prove this theorem fn plus 2 is. Let's say you have a series fn plus 2 or sequence fn plus 1 plus fn, and f1 is 1, f2 is 2, and I hope to show that take a square root of n fn plus 1 greater or equal to 1 plus 1 divided by f of n, take a n square root. So before I start, my channel is MaxGeeks. Please subscribe to my channel and leave the comment. You can leave the comment as I subscribe and then click the like button. Okay, so do not waste time. Let's think how to solve it. So usually, if I see such equation, right, you take a square n. You take n roots. And what I already come into mind is the arithmetic progressions greater or equal to geometric progressions. Arithmetic mean greater or equal to geometric mean. So let's say you have a1 up to an greater than or equal to 0. You have defined am arithmetic mean to be a1 plus a2 up to an divided by n. And the geometric mean is just the product. Take a square root. Take a n roots. If you product n of n, take a n roots. And the result is basically arithmetic mean greater or equal to geometric mean. Okay, and you can prove this by mathematical reduction, and I will leave the video video link below, or basically you can check here to see the proof. Okay, so ideally is that we want to use this fact, right? These two facts to give us this, right? Okay, so let's see how to solve this. So let's see the proof. So let's see that. I can write fk plus 1 to be fk plus sk minus 1, right? So, and since we only have, right, we have f1 is 0, f1 is 1, f2 is 2, right? So I can define f0 to be 1. So this is crucial. Why I define f0 to be 1? So that means these two sum will be this, right? So this is just the reasonable choice. Okay, and I divided fk plus 1. So I have this, right? So I can check k from 1 to up to n. So I can sum all of it. So I get n equals to k from 1 to n, fk divided by fk plus 1, sum k from 1 to n, fk minus 1, fk plus 1. Okay, and remember that we have this arithmetic mean greater or equal to geometric mean, right? So what I can do is that this term, let me just write it at right hand side, divided by n, right, will greater or equal to the product, right? So fk plus 1, k from 1 to n, right? And what is this? So this term is just f1 divided by f2, f2 divided by f3, fn divided by fn plus 1 over n. So use your small right? At f1 is 1, right? So it's basically this term is just fn plus 1. And fn plus 1 then take n roots, right? So this term will greater or equal to n. Let's maybe use n of it. So this term, this n, will less greater or equal to this term can be replaced by this. Okay, so this is the first term, and then let's do the second term. Okay, so the second term is this, right? So let's k from 1 to n, fk minus 1, fk plus 1. Right, so this term divided by 1 over n, right? Divided by n greater or equal to the product. So k from 1 to n. Right, so this term is f0 divided by f1, f1 divided by f2. F0 divided by k is 1. Right, so f2, so f1, 3, up to f minus 1, fn plus 1 over n. So you see, still cancel, right? But it cancel alternatively. So, by the way, this is 1, right? And this is 1. Right, but I want to say is f2 cancel, right? So it keep cancel, right? But there will be remaining two terms. One is this fn plus 1 and f of n, right? So there will be two terms survive. So this term will be square root fn plus 1. Right. So so we get this. Okay, so finally let's delete n, right, and take the n fn plus 1, right. So finally you get the let me see, yeah, take this. So finally you get this. N take a fn plus 1 root square root equal to 1 plus 1 over square root of fn. Okay, so very hard quick problem. Hope you guys subscribe to my channel. See you guys in the next video.